Okay, Algebra 1, 8.5. This is factoring using distributive property. We are going to go in reverse. Factoring, guys, is what I'm going to call is breaking it up. You're going to break it up. And when I say to factor something, it means factor it completely. Or break it into its smallest pieces possible. So the first thing we're going to do and work with a lot today is the GCF. What does a GCF stand for? Greatest common factor. So what's the biggest number or variable or expression term that's in everything? And so we'll start off on this page with 27y squared plus 18y. So you look at those things, and it doesn't matter if there's 2 terms or 8 terms or 25 terms. You look for what is in every single one. Factoring, guys, only can happen if every single one in the group can give it. So this is the task for today. I'm going to go to class and I'm going to say, okay, everyone, take out your money. You guys all owe me some money, okay? But here's the stipulation. You guys only can give me what everybody can. So Ethan pulls out of his pocket and pulls out $7. So now everybody owes me $7. Okay, Megan opens up her wallet. She says, I only have $3. Well, guess what? Now everybody can only give $3. Dave says, I got no money. So guess what? Nobody has to pay me. Okay? So that's how it works. Excuse me. Didn't pause it in time. Okay. Anyways, keep going. So looking at that group, look at the numbers first, the coefficients. What can go into 27 and into 18? 9. So yes, 9 can be factored out. And then I move on to the variables. A y squared and a y. What can they all give?
3.
Oh, we already got a 9.
Y.
We're talking about the y's now.
Y.
It's a y. And so basically what's going to be left is the stuff after I divide out 9y from each of those. So you're taking 27 divided by 9.
3.
3. Y squared divided by y
Y.
is y. 18 divided by 9 is a positive 2. And y divided by y
Nothing.
is 1. So you can leave it as a 2. This, guys, is factored using the greatest common factor. So what we have here now is negative 4a squared b minus 8ab squared plus 2ab. So again, I know that it looks like I'm going to be able to factor out something of all of these. If you can't, then this would be it. You would say this is your answer, it's not factorable. But negative 4, negative 8, and 2, I think we can take something out of those. What can we take out of all those numbers?
AB.
2.
We can take a 2 out, right? So it means I can take a 2. And if I look at the... So A is in all of them because the first one has a squared, the second one has an a, and the third one has an a. So they all can donate or give an a. What about B? Can they all give a B?
Yes.
Yes. So I could take a 2ab out. Guys, this is not the only necessarily the answer here. I technically could have took negative 2 off of everything. It would just change the sign of everything. But now I go through and I divide all 3 of those terms by 2ab. What's negative 4 divided by 2?
Negative 2.
It's negative 2. What's a squared divided by a?
Negative 4.
It's a. And what is b divided by b?
Nothing.
Gone. Right? Goes to 1. It's gone. Then, what's negative 8 divided by 2?
Negative 4.
Negative 4. A times a divided by a?
Nothing.
Nothing.
B squared divided by b?
B.
B. And, wait a minute. 2ab divided by 2ab.
Cancel.
It completely cancels out.
It cancels to what?
1.
1. And it's a positive 1. Guys, it's important that you have that placeholder there because, guess what? I can check my answer by distributing the stuff I factored out back in, and I should get the original answer. It's a wonderful thing. So now we're going to factor by grouping. This means it has 4 terms. It actually could have 6 terms, 8 terms. It doesn't matter as long as it's an even amount of terms. What you need to do, I got some steps on the side there. It says you need to put parentheses around the first 2 and last 2 terms. And then you're going to factor each of those groups themselves to get a common factor of the same factor inside the parentheses. So when you pull stuff out, it's going to be left with something that's the same. If you can't make it the same, then you can't factor by grouping. And then in step 3 says you're going to now factor out that common group. And what you're going to do then is for maybe put outsides together. Being very general here, very vague about this, and I'm going to show you how to use it in these steps here. But you're going to find out that the outside pieces that were outside now get pushed together and become their own factor. So, here we go. When I have this, I'm going to put parentheses around the first 2 and the last 2. Now, it's important, guys, that you include the sign on this particular problem, the one on the 3Q. This sign gets included in this second group. I am then going to take each of these groups, and I'm going to say, hey, I can factor something out of that group. What can I factor out of that first group?
You can factor out
4 and?
Q.
What else is in the first group? What's in
8.
4QR plus 8R?
Q.
What am I saying twice? I don't say Q twice. R.
No.
I could take a 4R out. Can you guys see that?
Mm-hmm.
And if I take a 4R out, what's left?
Q.
Q.
8R.
Plus?
8R.
No, it's not 8R.
3.
It's 8R divided by 4R.
Please go to your 8 period test, 8 period.
So it ends up being a 2.
What?
I'm dividing 8R divided by 4R.
Oh,
8
okay.
divided by 4 is 2. R divided by R is gone. So it's just Q plus 2. Is everybody okay with that? I am going to do the exact same thing with this other group. What can I factor out of this group?
3.
A 3. Now this is why I left the sign inside. It's not just 3, it's a
3Q.
It's a positive 3. So I'm going to take a positive 3 out. What's left if I divide both of those by 3?
2.
Plus
2.
2. Hey guys, step number 3 says factor the common group out. What do I have common? I have a Q plus 2 and a Q plus 2. Which means I am going to take a Q plus 2 out of both of them. I am basically using the distributive property in reverse. Bump. Bump. And what's left are the outside pieces. And I just push them together. 4R plus 3. You just factored by grouping.
Eat.
If you don't believe me, foil that together, you'll end up with the original problem.
I believe you.
I do.
Now, the problem is here, guys, is that it wants you to use this property that's called zero product property. Zero product property. If I had two numbers, A, B, and they equal 0, what has to be true? A times B equals 0. What would have to be true?
They're both 0.
They both are 0, or
One's
one is 0 and the other one's not. Because 0 times anything is 0. So that means A equals 0, or B equals 0, or both. So now guess what? If they give you something like x minus 2 times x plus 4 equals 0, can you solve for x and y, or solve for x? And the answer is yes, using what we just talked about. If those two things multiply to equal 0, it means that x minus 2 equals 0 or x plus 4 equals 0. Can you solve them individually? Add 2, x is equal to 2. Subtract 4, x is equal to?
-4.
You just solved it. Okay? So therefore, we can solve them using the zero product property. So, there are going to be times where they're going to give you problems that are set up, just like this one. There's going to be other times they're going to give you a problem like this, and they're going to say it equals 0, which means I factor it, and when I factor it, that means this is also equal to 0, the whole thing. I didn't change the problem because I factored it, which means that q plus 2 is equal to 0, or q equals -2, yes? And 4r plus 3 equals 0. This one might take a little bit more thinking. Subtract 3, and then divide by 4. So r equals -3/4. So this is while we're going to solve problems. You're solving by factoring.
Transition student